Well, good evening. Welcome to Space Oddities. Here we are, a day after the Great American Eclipse. So this evening we'll be talking about that. And we hope to have a report from our American correspondent who should be beaming into us hopefully at some point. He's on his way back from the eclipse across America, and he's hoping to find somewhere with Wi-Fi so that he can give us a report on what he saw and what the experience was like. So if you have any views or images or even videos of the eclipse, if you were there, we'd love you to submit them to our weekly viewers gallery, and you can do that by sending them in an email to spaceodditieslive@gmail.com. One image or video per email, please. Bit of explanation about the detail, and if you could remember to put in the title of your email something that includes the word gallery so that it will be automatically picked up, that would be fantastic. So welcome, viewers. We hope you're all well out there. Hope you've had a fantastic week. It's been quite a week for astronomy or astrology, depending which media outlet you read. So we'll talk about that in a bit, but I'm delighted to welcome this evening some of the usual suspects. Good evening, Michael.
Good evening, Andy.
How are you?
Fine, thank you.
Yeah. Okay. And Roger, how are you?
I'm fine. I'm all excited. I've got clear skies tonight.
Oh, no, you haven't. Yeah, I have actually. It's lovely clear. It's been raining all day, but we've got clear skies to follow, so the atmosphere is nice and clear.
Mm-hmm.
How are you, Daz?
I'm fine, thank you. So I'm just fiddling with the volume on YouTube. I've set up these things a little bit different this week, see if I can, because I'm always stretching up and cutting myself out. So hopefully we'll resolve that. But
Daz, the exercise does you good, mate. It's the only one you get.
God, hang on, it makes me sweat. And a sweaty Daz, that's nice.
And sitting in front of an eclipse, by the look of it, is Keith this evening. How are you, Keith?
Hi, I'm fine, thanks. Yeah, it's been it's cleared up here too, so I think Roger and me ought to get outside at this point and leave you guys to get on with it. But,
okay, be like that. Be like that.
It's been windy here, and I had a power cut earlier, so I'm glad I'm back. So
we're glad you're back too.
Actually, clear here as well.
Oh, right.
We've got high winds. We've got trees down here at the moment, so it's all good fun and games. But there you go.
There we are. So there we are. So it's been quite a week, as I said. It was you've probably seen it on the news, all the coverage of yesterday's total eclipse across America. And as I said, we'll be going into that in a little bit of depth later. But we've also going to talk about eclipses more generally and historically this evening. So we hope you'll stay with us to watch that. First of all, a big thank you to Gerard for the super chat. Very kind of you, sir. Your generosity seems knows no bounds. So thank you very much for that. We do appreciate it. All goes in the coffers and helps keep the ship on course, as it were. So let's make a start then by saying that don't forget the Space Oddities merchandise is available. And I'll just put those up so that you can see what we're talking about. The Space Oddities T-shirt, available in 10 colours, £20, including UK postage and packing. There we are. Keith is rather helpfully being the Turner for this evening and pointing things out. And it's a good game. And you can scan the code, or if you look in the chat, there will be a link that's just popped up in the chat, and it's also in the description of the video, as always. We've also got the Space Oddities hoodie, 6 colours available, 2 designs over the head or a zipper, with the design on the front and the back of the garment, respectively. That's £40, including UK postage and packing. And then we've got the not that one, this one, the Lapel design T-shirt with the Space Oddities design on the lapel. And again, this is £20, including UK postage and packing. Add another £3 if you want a long sleeve version. Please add £10 to the total of your order if you're ordering from outside the UK. So that's that. Don't forget that you can actually support Space Oddities by buying us a coffee. And we are very grateful for any coffees that you might want to buy for us, because again, it all goes into the coffers of the channel and helps keep the channel going. And you can scan that link, and we're very grateful for your support. As regards the merchandise, we got some news for you. We are going to introduce a new T-shirt for the summer, a new design, and we will be asking you, the viewers, to decide which design that will be later. So do stay tuned, because you'll get the chance to choose which T-shirt we're all wearing for the summer. So we're really looking forward to giving you something new to wear when you're out strutting your funky stuff in your Space Oddities T-shirt. So we will ask you we'll just do a quick poll amongst everybody who's watching to decide which design you would like to have on a T-shirt, and hopefully a hoodie as well, for the summer. And we'll do that a bit later on this evening. Now, let's start the ball rolling then in time-honoured fashion, and go to Roger, who is going to, as usual, tell us all about the night sky. And no Rachel this week, I'm afraid, because it's Rachel's birthday today. So we would like to wish Rachel a very, very happy birthday.
Happy birthday, Rachel.
She's out celebrating.
Rachel.
And so therefore, Roger's doing the gallery very kindly for us again this evening. So, Roger, then I guess it's over to you.
Thank you very much. Okay, so after yesterday's eclipse, it's all a bit of an anticlimax, I'm afraid. So this was what the sun looked like today from my back garden. There are a few spots available, but nothing very much. But at least there were some interesting prominences on display when the eclipse occurred. So that pleased quite a few million people, I'm sure.
Yeah, there are some, like you say, some sunspots on there.
Yeah.
But I did notice, I was checking earlier on, the sunspot count for last month dropped drastically, and we're back below what they thought the maximum would be. So maybe we're not going to double peak, and maybe we're on the decline, but we will see. Okay.
Absolutely. Anyway, so we're now following on from the new moon, which we had from yesterday, leading up to the first quarter for next week. And obviously with Jupiter out of the picture now as of 10 o'clock through this week on my stellarium slides, we're a bit barren of planets, I'm afraid. If anyone was able to see anything yesterday, they probably would have noticed Venus and Jupiter, but whether they would have noticed any of the others would be very much debatable with the brightness of the corona. But no one has mentioned that Pons Brooks was visible either, but I'm sure the corona probably glared that out of the way, unfortunately. But at least all 7 planets were up there to grace the eclipse. But as you can see, we've still got 4 planets leading sunrise and 3 trailing the sunrise. Obviously, you can't see it quite like this because the sun will be glaring out too much, but it just gives you an idea of the positions of the planets this week as the week progresses. And an interesting conjunction, which was for the 11th, 2 days' time in the morning, where you've got a close conjunction of Mars and Saturn. And they're very close together. So that might be an interesting one to capture. But obviously with the closeness of sunrise, it might be much of a challenge, let alone having a clear low eastern horizon. But an opportunity is an opportunity. So for this week, I've put Comet Pons Brooks and 13p Obers on the same illustration because they are quite close together in the night sky relatively, and could be quite an interesting photo opportunity, although they are too far away unless you have a really dark sky and clear seeing to get them both in the frame. But there is an opportunity for one to be seen after the other because Pons Brooks is now getting a bit low in the sky once it gets dark enough to be able to see it. But there is a possibility, and the brightness is still improving slightly for Pons Brooks, but unfortunately for us, we won't be seeing that for too much longer. But as you can see on Obers, between the beginning of April and the start of May, it will brighten up by 2 magnitudes. So it's really starting to come onto its own.
It is.
But obviously, as time progresses, its position will become more and more difficult as Taurus sets into the western horizon. But we'll see how that goes. We do have an image from the James Webb, which is of the Cigar Galaxy M82, which is gaining some interesting information from what it has surveyed in relative terms to what the Hubble has managed to resolve. Although the Hubble has produced some rather amazing images. But yes, so it's just a matter of see what you can see. Right, we have a very, very small gallery, so won't take long to go through them. We've got Jerry with the Seagull Nebula, with his Zenith Star 61, and 15 5-minute exposures.
Oh, wonderful.
Very good. Yeah.
Very good, Jerry. Fantastic.
Yeah. Of course, that is now getting a bit more difficult. Now it's getting into the western horizons now with Canis Major and Orion all setting down in that area there. So good job to catch that. It's quite interesting to see the bow wave on that bright star in the on the lower left there.
Oh, yeah, you can. Yeah.
Quite a good demonstration of the bow wave shock there.
Yeah.
Well done, Jerry.
Yeah, well done, Jerry. Thank you.
And then there's one of mine. This is a more recent one that I've done of M81 and M82.
Nice.
So
very nice.
Very good. And then after this one, here's one that I took about 5 years ago when I'd only been about a year into my astrophotography. If I can, of the Trifid Nebula.
Oh.
Mhm.
Oh.
Nice, yeah.
Yeah, it's one of my early attempts at the Trifid. Unfortunately, I hadn't quite got so much of the blue part of the nebula, but on the whole, it didn't turn out too bad and got quite a lot of star cover.
Yeah, indeed. Well done.
Yeah, that's nice.
Fantastic. Look at that.
I was almost knowing what I was doing at that point. And that's all I have, I'm afraid.
Okay.
Yeah, fantastic. It was lovely.
Right.
Thank
Okay. So, our American correspondent Lou is he's just tried to access, but his bandwidth in America is low. He's en route. He's actually in his car, although not driving, obviously. So he said he's heading for Starbucks to see whether he can get a decent signal in Starbucks Wi-Fi.
It's appropriate.
He definitely won't get any decent coffee, that's for sure.
Well, I'll have a cappuccino.
Yeah, absolutely. So what we'll do, we'll come over to Daz. Daz would like to speak to you about something. So over to you, Daz.
Yeah, just as a bit of fun, I thought what we might do is we might start challenging your little grey cells. And what I was thinking of doing is probably, every week, hopefully, if I can think of a couple of questions, is just to throw you a couple of questions, which they're not going to be, scientific. They're not going to be physical equations or anything like that. Just simple questions that we can ask you at the beginning of the show, and then we'll give you the answers at the end. It's just for fun. Even if you have to go and look the answers up, that's all well and good, because it's all about learning. Because virtually every time we do a show, I learn something. So it's just one of those things. It's just something just to give us a challenge, our little grey cells, wake ourselves up before we get into the serious stuff. So basically, what I would like to do, and I hope you can all see this, is the first question is, now, I will admit, I'll be surprised if most of any of you get this, or hopefully some of you will, because this was an event that happened literally, or was advertised literally as the show shut last week. Because when we went off air, we were all sat there and we were staring at this and we were amazed. So there's a bit of a clue there. This is a very recent event, and if you've seen it, you'll know what it is. So
Is it you buying around, Daz?
That'll never happen, mate.
No, I was going to say
that'll never happen.
No.
That's like finding dark matter. That'll never happen. So there we go. So right, what we'll do is no, let's see if you can see. Now I hope you can see this. Basically, the question is, what is this showing? I'll let it run for a couple of seconds.
And this is a truly amazing video.
It is. We'll give you some background into it later. We give you the questions, but it is absolutely amazing, and it's something that we probably thought we'd never see, to be quite honest. There you go. Right, okay, then. So that's that one. So basically, what is this event? Right. So the next question is, when you're reading through non-fictional books, especially astronomy books, you'll sometimes see signs that are like this, a round circle with a dot in it, which actually represents, it's shorthand for the sun. So this symbol represents the sun. And it's basically a hand-drawn emoji that scientists use because they love doing the science, they love discovering things, but they hate writing it up. So they try to use shorthand. And this is a symbol that is used for the sun. And you may have seen them. So what the question is now, I'm going to ask you, and sorry about the quality, they'll just grab this screenshot these thing, is can you name these 3 planets? I'll leave it up there for a while. If you want to screenshot them or just quickly jot them down on a piece of paper or take a photograph with your phone. So what 3 planets do these symbols represent? Simples. And we will come back and we will give you the answers towards the end of the show. So
okay,
in caps on.
Okay, fantastic. Thank you so much, Daz. I'm sure our viewers will look forward to seeing the answers towards the end of the show. And talking of questions, now we're going to go over to Keith.
Yep. I'll put up my thing. Hang on a minute. Well, it's appeared under my...
Okay, there you go.
There we go. Yep, fantastic. Right, my quiz is a visual one. And what we're going to do is show you some pictures of objects which might be meteorites, or there might be something that's commonly mistaken for a meteorite. And again, you'll get the answers at the end. But basically, we're going to work through them now. So here comes specimen A. Take a good look at this. Is that a meteorite or part of a meteorite, or is it not? And we'll move on then to specimen B. Okay, it's the dark thing we're interested in here. Is that part of a meteorite or a whole meteorite? That's the question about that. I've put a scale underneath it and it's got words pebbles written on it, but that's not what it is. But nonetheless, you've got to decide whether that's a meteorite or not.
Is it the rear end of a squirrel burrowing into a tree?
It does look a bit like that, doesn't it? Yeah. Okay, and we'll move on to specimen C. Okay, is this part of a meteorite or not? Have a think about that one. By the way, I should have cleaned my fingernails before taking this picture. I apologise for that. And specimen D, again, we're interested in the dark object in the middle. Is that a meteorite or is it not? And we'll then move on to specimen E. Is that a meteorite, or is it something else? I pinched this picture, by the way. It's not one of mine. The rest are, but this one isn't. Okay. And specimen F, which is quite small, as you can see, because I put a penny next to it. Is that a meteorite or not? It's obviously been polished before being presented, so bear in mind it has been sort of interfered with by people, but nonetheless, is that a meteorite or not? And then finally, the last one, specimen G, coming up here, is that part of a meteorite or is it something else? And as I say, I'll tell you the answers at the end. Some of those objects, by the way, that you have seen that are not meteorites, and I'm not saying which they are, have commonly been mistaken for them, and I'll explain all that at the end. Okay then, thank you very much.
Right. Now, actually, I thought I'd be able to instantly or easily recognise meteorites, but I'm not so sure now.
The thing, it's quite deliberate in a way. I picked obviously things that get mistaken for meteorites, hence the fact it's harder to pick the right ones from what you've got there. If I picked something that was very, very different, you'd know straight away.
Yeah, absolutely.
But then so would everyone else. They wouldn't turn up at museums with them in their bags, and things like that.
Tell you what, Keith, just for the viewers, if we put this back up, can you just page fairly quickly backwards through them just for a final look at them?
Yeah, right, hang on then. Let's look. There's G. Okay. And here's F. And here's E. And here's D. And
that's interesting.
Here's C.
That looks like nougat.
It does, doesn't it? Yeah. And B.
The squirrel.
The squirrel, yeah. And finally A.
Fantastic.
And there you have it. Okay.
Thank you so much, Keith. I shall look forward, and I'm sure we all will, to finding out the answers to that at the end of the programme. Okay, well, as our American correspondent Lou hasn't seemingly managed to connect yet, I think we'll go on with the news for this week. No surprises that the big story of the week is the eclipse. So just give me 1 second, and let's have a look. So this is leading up to the moment of totality, video courtesy of space.com and NASA. Let's have a look. And this is something I'm looking forward to seeing in 2026 for the Great Spanish Eclipse. And look at the flash. Absolutely unbelievable diamond ring appearing there. And then coming up to just a few seconds within totality, you can see on the left there what it looks like. And there you have it. Absolutely unbelievable. So it all went off well. Well, he wasn't going to do anything else, really, was it? But there were, millions of people watching this across the US and Mexico, of course, because it made landfall in Mexico. The path of totality. So there we are. So that was the eclipse. That was the moment of totality.
Andy, do you know if that photograph's got clouds surrounding it? The reason I ask is the corona looks very, I don't know, misshapen.
I don't honestly know, Daz.
Yeah, no. So just no, because I know in some places they did have some cloud cover, and other places they were totally clear. No, that's fine. Thank you. So I just thought I'd ask.
Of course, as we're coming up to solar maximum, the corona was somewhat bigger than it has been in previous eclipses.
Yeah, it just doesn't look the right shape. That's what made me think.
Yeah, I don't know. Keith, have you got any thoughts on that?
Yeah, the corona does vary in shape, as you say, between solar minima and maxima. If I remember right, maxima, it tends to stick out in all directions, like it's like hairs.
Yeah, it looks like it's got wings when it's at maximum, but that.
Yeah, you're right. Yeah, you get those sort of along the equator line. Yeah.
Keith, did you see the NASA image of it? Fully showing the corona. It was amazing, absolutely. Amazing.
I really must check that. Yeah,
it's. I'm sure it's on the NASA website somewhere. Okay, but of course, humans being humans couldn't let this eclipse pass without, of course, paying tribute to thousands of years of superstition. So there were a lot of conspiracy theories going around the internet about what was going to happen during and after the eclipse. The following things did not happen during or after the eclipse, as far as we're aware. So these are just some things that were predicted to happen. Firstly, Jesus did not return to Earth. Sorry. Secondly, lots of people on American social media have been saying that there was going to be a mass human sacrifice of around 900 people by, then take your pick, the Democrats, the deep state, the Illuminati, Satanists, atheists, LGBTQ. This is all true. You can go and find these yourself.
I've seen it. Yeah.
Yeah. One I didn't mention there was the inevitable them. So, that didn't happen either. There was no massive earthquake during the eclipse or after it, either natural or artificial, because there was a conspiracy theory going around, let's see if I've got this right, that they, unspecified, were going to generate an artificial earthquake to divert attention away from the fact they were sacrificing 900 people. So, Yeah, I kid you not. I read that myself. The rapture failed to happen. Again, no massed ranks of Christians rising into the sky. Aliens didn't make contact. Sorry, that was another thing that was predicted. And the Earth didn't end, as we now know, because we're still here. So none of these happened. So you can all rest easy in your beds tonight. But also, after the eclipse, there was a peak in Google searches for a particular phrase. Now, I wonder whether any of the panel or any of the viewers out there can guess what phrase peaked in Google after the eclipse. Anybody want to guess? If you know this already, don't say so. But if you don't know, have a guess.
We're all going to keep quiet now. Pretend we know.
Don't tell me. Was it President Biden's fault?
No, not that. Any other guesses?
Trump's the Messiah?
No, nothing to do with politics.
Right. Okay.
When is the next one?
No.
We have a new word at NASA we're trying to circulate called magnetosference.
Oh, welcome, Lou. Glad you got in.
Thank you. It was tough going there for a bit, but I'm glad to be with you.
Yeah, we're glad to have you. We'll be with you in 1 second. Okay. No more guesses? Any viewers want to put anything in the chat? What phrase do you think peaked in Google after the eclipse? Just give you a few more seconds. No. And this did make me laugh. It was...
Yeah.
Oh, no.
Absolutely true.
No.
Absolutely true. Why are my eyes hurting? That peaked quite considerably in Google after the eclipse.
No.
So there we are.
Yeah. Just got some things in the thing. Says Robin Echo said we had a beautiful sun halo throughout the eclipse in Montreal. Even during totality, the halo dimmed but did not completely disappear.
Right.
Right. Okay. Well, we'll come back to the news later because we have, we don't know for how long, our American correspondent Lou. So I don't know whether Michael keeps hogging the screen like that. Anyway, no. So how are you, Lou? How was the eclipse?
It was amazing. We had weather maps had been produced, of course, for months before the eclipse. Where should you go? Where's the best chance of clear skies? And of course, everyone went to Texas because that's like the best chances.
Yeah.
It was not. It was cloudy and rainy all along the path in Texas. And up in Carbondale, Illinois, at Southern Illinois University, where I was, where we had, it was predicted 50-50 chance of clear skies. They were crystal clear.
Wow.
And we saw the entire eclipse.
Fantastic. And where are you at the moment?
I don't know. We are in rural America. I think we might be in Indiana, and we pulled off to find a McDonald's that has free Wi-Fi.
Yeah.
Because my hotspot on my phone was just not cutting it.
No.
So I'm somewhere in the middle part of the country. Again? I'm in the town of Ferdinand, says one gentleman.
Oh, say thank you very much to him.
Yeah, thank you, Ferdinand.
Ferdinand, Indiana.
Fantastic. So this was not your first solar eclipse, though, was it?
No. I've been asked this question many times. How many eclipses have I seen? Well, there was one when I was a child, I remember. It just happened to go over my house in a partial phase. So I guess that counts as one. Then I was in 1999. I was in France for it. Saw the partial phase clouded out during totality. And then 2017 at Carbondale, saw totality. And then this one.
Fantastic.
So that, I guess I consider myself an eclipsophile, and already looking at the maps for Spain and in 2026, your area, Andy.
Yeah, you and I might finally get to meet then, Lou.
Wouldn't that be?
We definitely will if you come.
Crazy.
Well, as I said, I'm going to the city of Valencia, which is 3 hours south of here on the train. And looking at the stats, there's a 67% chance of clear weather. So not too bad.
Good. It's pretty good.
Yeah, that's pretty good. And no chance of rain. Absolutely no chance of rain.
But you also get a second chance in the 2027, don't you, Andy?
Yes, but I have to go right to the southern tip of Spain for that. But I will do that if the 2026 eclipse doesn't pan out. I'm definitely going in 2027 because you're even more, because it's further down towards Africa, of course, just north of Africa. Yeah, you're much more guaranteed clear weather in August.
Will they allow reservations yet for August of 26?
No. None of the hotels are taking reservations for 2026 at the moment. And commercially, it makes sense, for them to wait and take their bookings much nearer the event and put the price up 10 times. So,
and they will.
They will. Of course, they will. They'd be stupid not to, wouldn't they? From their point of view.
We had rooms at the Hampton Inn in Carbondale, which are usually $98 a night. It's fine. Just for NASA, they only bumped it up to $300 a night, and then they screwed up a couple of the reservations and said, "Well, we have to cancel them now and rebook you." And they tried to rebook these people for $500 a night. So,
what?
This is not right. This is a wonderful celestial event. You shouldn't be making money off it, but
exploitation.
People do. But by the way, my presentation, it says is uploading, and
right.
It may take a little while longer, but it claims it's continuing.
There's just one. There's one more comment in the thing from Bob. He said, "I saw a red spot flare at 5 o'clock. Yeah, that was very, very obvious. Here in Grand Prairie, pretty sure it wasn't a defect in the ISO proper glasses. No, there was definitely something going on. There was a CME or something happening at the time.
No, not a CME. Not a CME. We all saw it too. It is a prominence from the chromosphere.
Oh, okay then.
Yeah. We had the eclipse streaming in white light, and by the way, during totality, you can see it in just a white light image, but also hydrogen alpha and calcium K.
Yeah.
And that was the big question mark. Here we are at the peak or almost at the peak of solar activity, the solar cycle. Will we see a major eruption during the eclipse? And no major eruptions, but
it goes on to say, I got a totality, one-sided full body tan and blindness. But something that was mentioned when he mentions ISO, there was something that somebody was talking about. They were going to use welders' goggles and welders' glasses. Now that's all well and good, but you've got to make sure they're to the right specification and that they actually block all types of radiation, because a lot of them, they just block out optical light, and they will not block out the UV or the infrared, and they will still damage your eyes if you don't use the correct ones. So always be careful. Never look at the sun with bare eyes, or you have to have the right equipment.
We had this problem at NASA in 2017. The ISO standard is ISO 12312-2.
That's that, yeah.
And so you might say, well, if that standard is printed on the glasses, you're safe. Not always. There were companies, I won't mention any names, that were printing those on their glasses, and they weren't ISO certified. So NASA had opened up a competition for best bid on some number of millions of glasses, and we got them, and we couldn't verify that they were ISO certified glasses, and we dumped them, and had to get new glasses. So it's best, I find, to buy from a reputable organization. Some of them, Rainbow Symphony, American Paper Optics, Lunt Scientific, and there are others, of course. But it's hard to tell.
Yeah, absolutely.
Yeah,
okay, Lou, listen, while your presentation is uploading, shall we just, there's only one more news story to cover, so let's do that, and then we'll come back, and hopefully by then your presentation will have uploaded.
Sounds good.
Okay, so just one news story that was well, quite, not quite, but amazingly astounding for me. Now, you may remember that the iconic picture of the black hole in M87 that was imaged in 2017 by the Event Horizon telescope. I'm sure you would have seen this many times. We've talked about it often enough on this show. So this is the black hole in M87. But then they made a discovery that the radio light from the black hole in M87 is actually polarized. And when you look at the polarized light, this is what it looks like. That spiral is actually tracing the magnetic field lines of the magnetic field around the black hole. Now, this came out, I think, last year, about June or July last year, I think, if I remember rightly. So for the first time, we were actually able to see, more or less, the magnetic field around a black hole. And it did behave, or does behave, according to predictions. But this is an important step forward because we've never been able to directly measure the magnetic field in this way before, let alone see it. So then, of course, we have the image of the black hole in our own galaxy, Sagittarius A star. So scientists wondered whether the same thing might be true of the black hole in the middle of our own galaxy, which, as you know, is Sagittarius A star, the designation, 26,000 light years away at the center of our galaxy, the mass of 4 million suns. Anyway, when they processed the image in the same way, guess what they found? On the right-hand side, we see, what do we see? The magnetic field around the black hole supermassive black hole in the center of our own galaxy. Now, this is important because it's amazing how similar the two black holes are. So the question is then, is this the standard configuration of a magnetic field around supermassive black holes? Will we see the same thing in the future with images of other supermassive black holes? So this is incredibly exciting because it allows scientists to probe exactly what's going on in the environment around the black hole. And they say that, the strength of this magnetic field can directly be attributed to what we see in terms of jets from M87. You're probably aware that M87 pumps out jets from the outside of the black hole. Of course, nothing can come out of the black hole itself. And we find with supermassive black holes, and indeed solar mass black holes, that the gas and material that the black hole is swallowing, black holes, they're not fast eaters. And some of the material does not get eaten by the black hole. It's sort of regurgitated from the immediate surroundings. It's channeled to the poles, the magnetic poles, by these magnetic fields that you're seeing, and ejected across space as these jets of plasma, which are very tightly focused. And the jet coming out of the center of the M87 galaxy, there are two jets, and each of them are 5,000 light years long. And it requires an incomprehensible amount of energy to push out a jet of plasma that's 5,000 light years long and keep it sort of focused, as it were. So now we can actually see the black holes, and we can work out, exactly, well, not exactly, but we get a much bigger handle on the whole process of these jets coming out of black holes. So the intriguing question is, does Sagittarius A star have a jet that we're not seeing for whatever reason, because of the technology we're using, or there might be just one jet that's pointing away from us? We don't know. But the suspicion is that if that magnetic field around M87 star is responsible for generating its gigantic jets, then we might see a jet or even two jets coming out of our own supermassive black hole. Of course, our own supermassive black hole is a little unusual for lots of reasons. Firstly, it's very quiet. It's really quiescent at the moment. It's not doing a lot. And this means that maybe the jets aren't produced because it's not actually productively eating material. But we don't know. And these are all areas that are being heavily researched at the moment. So there we are. A very, very exciting look at the magnetic fields around the supermassive black hole.
That's intriguing, Andy, because I don't know if you, looking at those, they almost look like they're spirals.
Yes, that's right. They do.
And you know what I'm going to produce? My slinky.
Oh, God. Oh.
I was just wondering whether or not these, if they're spirals and they're spiraling out, could they be forming like when I was talking about the magnetic rope flux, that they form a tunnel, and the actual jets, the material in the jets, is trapped inside the actual tunnels?
Well, we know, Daz, from I forget. I think it was Centaurus A, the black hole in Centaurus A. They have measured magnetic fields encasing one of the jets. Definitely.
Right.
I don't know out to what distance, but
Yeah.
but check out Centaurus A, Daz, because
I will do.
I'm sure that I may be wrong, but I think that's what I remember reading.
Because it looks like we're almost looking down the end of the slinky, and you can see the spiral lines. And of course, we know from the sun that when we get these flux ropes, that all the material and the energetic particles are trapped inside, because they're just racing up and down the magnetic field lines that are trapped inside. That's fascinating. I will be looking at that.
Yeah, definitely. By the way, comment from Ammo Cat Dog. I want to go to Spain with Astronomy Ireland. We'd love to see you. I will be there. It'd be lovely to meet you. I hope everybody from Astronomy Ireland can make it over, because I'm sure there's going to be an awful lot of people here. So yeah, we'll have to keep in touch, and we can all meet up somewhere. So there we are. As I said, I'll be in Valencia, because that's the closest place to me on the line of totality. But if you just Google Total Solar Eclipse 2026, there's a wonderful everything you need to know page, which I think is the first hit in Google, that gives you every bit of information you could possibly want about every single country where the eclipse is visible from. So there we are. All right, so let's have a look and see how we're getting on with Lou's presentation here.
Can you tell it what percentage it's loaded and all that kind?
No.
Okay.
No, it just says processing, uploading.
Great. Let me go back to the black hole for a minute. So we're obviously we're not seeing the magnetic field, we're seeing evidence for the magnetic field.
Yes, that's right.
Yeah,
Yeah, it's not the magnetic field
yeah.
itself. It's
And
Yeah.
so if you have some incandescent plasma, that will glow, and we will see evidence for that along magnetic field lines. But the plasma along these magnetic field lines must be moving extraordinarily fast
Yes.
and accelerating as we're seeing in a loop. So it's accelerating. And so that alone will also generate electromagnetic radiation, accelerating charge produces.
True.
And probably at the high energy end. So I wonder, has this been looked at spectroscopically? We have a beautiful image, and I wonder if a spectrum would be helpful.
I don't know, because it's just a radio image,
Mm.
so I don't know. I don't know. Could you get any useful information spectroscopically from just a radio image? You'd need a wider wavelengths, wouldn't you?
I'm thinking that you might be able to get a velocity,
Yeah.
the material,
Yeah.
and from that, perhaps you could get a magnetic field strength.
Yeah.
I'm just
Very
exploring.
intriguing. Yeah, very intriguing.
Because the wavelength it's around a millimeter that they're observing at. So I
It's
don't
not
know.
very high energy. Interesting.
Yeah. Well, believe it or not, they are going back to take another look at Sagittarius A star. I think this month or next month, to get some new images, because what they want to see is a change in the activity. They want to eventually be able to do video over periods of hours of black hole activity, because that's what the Event Horizon Telescope's aiming for. Because it's so close to us, astronomically speaking, the activity that you see can be measured in hours, whereas in M87, of course, it's vastly bigger than our own puny supermassive black hole, and activity happens over timescales of weeks rather than hours. So they should be able to get video of the activity around Sagittarius A star. That's what they're aiming for anyway.
Okay.
So there we are. So
Well, I tell you, I suspect this is taking a long time because a number of the images of the eclipse were taken with my Canon 70D, which is pretty high resolution, and those pictures are pretty big.
yes.
So if it doesn't produce results, soon, then I think we will have to delay that for next time.
Yes, definitely.
But I can tell you that the group that I was working with in Carbondale, which has representatives from the Adler Planetarium, they're on our team. Our team is called Solar STEAM.
Right.
Science, technology, engineering, arts, and math, STEAM. And so the Adler Planetarium, NASA Edge, who broadcast during the eclipse, Johns Hopkins Applied Physics Laboratory, in fact, I always get his last name wrong, Fawafi, who is the chief scientist for the Parker Solar Probe mission, was there, and we got him on camera many times.
Right.
And we have just a whole another group of members and volunteers, by the way, on this team. But when I got there, you'd think after we only had 5 months to plan, but we had 5 months to plan, and would think that maybe things would be a little more well laid out. But I found myself I'd have people come in, almost grab me in the collar, say, "You are on in 2 minutes. You're on air in 2 minutes. Come, go, go, go." And I was running across the field between different broadcasts and interviews, and oh my God, it was just exhausting. So I'm hoping I can tell a story with pictures, perhaps next time.
Yeah.
It was an amazing experience. 4 minutes and 8 seconds of totality, perfectly clear.
Yes, for the eclipse in 2026, we've got only just over 2 minutes. So,
but don't you have one coming up that is 6 minutes in length?
that may be the one in 2027.
That's what I'm thinking. There is one coming up that is 6 minutes in length, which is extraordinarily rare because the maximum time is, as all our viewers probably know, is 7 minutes, theoretically.
Yeah, absolutely. Yeah. All right. So, well, listen, Lou, we won't keep you from your journey if your presentation's not going to upload. Thank you so much for dropping in. And we wish you a safe journey home, obviously. And thanks for letting us know what it was like. They say that no two eclipses are the same, that each eclipse has its unique fingerprint, if you like, in the way it looks. Would you agree with that?
Oh, absolutely. There are a number of ways that these eclipses are different. One is that we are at the peak of the solar cycle this time. And so you would expect as we found, you expect the corona to be fairly uniform around. At solar minimum, the corona tends to congregate along the rotational axis of the sun.
Yeah.
Got it right.
Of course, solar activity and just the whole experience that you have with the people you're with, and it's an amazing thing. It brings people together. You get to share this eclipse. With I don't know how many thousands of people we had in the stadium, which erupted during when second contact happened and totality hit. It was just amazing. So in that sense alone, it's each eclipse is different.
Yeah, sure. And of course, it's important that children are there as well. Of course, we need to inspire the children, and there's probably nothing greater in astronomy that you can inspire children with than a total solar eclipse.
I imagine that for at least a few people, maybe more than that, young children, children in grade school or even above, were inspired enough to say, "Hey, I'd like to explore a career in astronomy or space science or aerospace engineering or something of that nature, just because of this eclipse."
Yeah, absolutely. And at least everybody, well, you think everybody would know what was going on. There was a lovely quote from a married couple at Niagara, and he turned to her when he saw all the people. He came out of a hotel or something, and they looked at all the people, and they said, "Do you think there's some sort of festival going on?" So I thought that was lovely.
It was the mass sacrifice. What are you on about? The mass.
Yeah, yes, it was a mass sacrifice. Of course, it was. But I remember a similar experience when Comet Hale-Bopp was in the sky. A woman in the street pointing at it with her son and saying, "What's that? What's that? Is that a jet? Is that a plane?" And I just stopped and said, "No, it's a comet." A comet? There hasn't been anything in the news about that. It's been all over the front pages for weeks. So humans are humans, aren't they? That's what makes us so lovable, isn't it? So
of course that did happen during the October annular eclipse in the United States just recently. Susan and I were in Albuquerque, New Mexico, and we got up quite early to go to the Hot Air Balloon Museum, which is where all the National Science Foundation and NASA and NOAA and everybody was selling things, and that's where everyone was set up. And we got on the road.
Wise out of that.
We got on the road around 7 o'clock, and the highway was already backed up for over 3 miles. And by the time we turned off, the police said, "No, you can't go. The parking lot's full. We're not letting anyone in." So there was a festival, and apparently they launched the hot air balloons quite early in the morning. So anyhow, we turned off and found a nice gambling casino to set up at. It all turned out.
All right then. So thanks very much, Lou. Of course, you're welcome to stay with us as long as you want, Lou, as long as your connection holds up. But
hang on and see. I think this connection has failed. I think that's what I see. So we'll.
Right. Okay. We'll save it all to next week. We look forward to it next week. So thank you for that. Thank you for dialing in. Somewhere in deepest Indiana, our American correspondent, Lou Mayo. So thanks very much.
Lost. Yes.
Yeah. And we'd just like to wish you obviously a safe journey home for the rest of the day.
Stay safe.
All right then. So there we are. Okay. Now the moment some of you have been waiting for at least. we are introducing a new design for the T-shirt this summer. So we've got a new T-shirt that we're planning, and we would like you, the viewers, to choose the design that you want to see on our new T-shirt, because we thought summer's coming. Let's have a change, and let's put something together. So I'm going to now reveal, in no particular order, the 8. Is it 8? It's 6. I think 6 designs for the new T-shirt. They are numbered. I have numbered them. So just really, viewers, if you'd be so kind, pick the one that you would like to see on a T-shirt and a hoodie, and just make a note and put it in the chat after we've been through them. So here we go. So this is choose the merch design. So here we go. Let me just do the thing here. Okay. So number 1 is this one. And they all say, as our current T-shirts do, if it's happening in space, it's happening on Space Oddities with the address of the channel. So that's number 1. Number 2. A few seconds. I will go back through them again.
I'm not seeing anything.
No, I was just going to say we're not seeing nothing.
You're not seeing anything.
Right.
Now, that's interesting. Why not?
Just got
We
text.
Okay, just give me 1 second. I can see that we've got a slight technical problem here. Okay, that's better. Right, let's try that again. Give me 1 second. Sorry, viewers, we seem to have had... Okay, let me just go back into this and just reset everything, and we'll give it another go. Right. Okay, let me just... Right. Okay, can you see it now?
We can see your first slide, yeah. Title.
Great. Okay, so here we go then. So, as I said, choose which number you would like to see on a T-shirt or hoodie this summer. So this is number 1.
Oh, wow.
Number 2. Number 3. Number 4. Number 5. And number 6. So I'll just go back through those. Number 6. Number 5. Number 4. Number 3. Number 2. And number 1. And just one more time. So that's 1, 2, 3, 4, 5, and 6. So there you have it. It's obviously a little bit of a departure from the current T-shirt, but in any event, we hope that you might like to wear one of those at least. If you don't want to wear any of those, don't vote. Simple as that.
Yeah, I see Derek can't count.
Why? Okay, right. So 1, 2, 3, 4, 5, 6. Anybody want to put a preference?
I like 1.
Yeah, me too.
That would also be my choice, but I don't want to prejudice anybody. Anybody going to prefer any? Put it in the chat, because if not, we'll choose it. But we'd prefer that you, the viewers, chose what T-shirts you would like to buy.
And can I just remind the team to choose wisely, and has got the power to kick you off. So
yeah, I have the power.
We have votes for number 8 and number 9. I don't know what that means.
Right.
We're overwhelmed, obviously.
Yeah,
So
typical.
we've got some numerically illiterate people watching, obviously. So, Ian says, I like number one. Are they Asimov inspired? Well, I actually created these with the aid of AI. The AI I used was actually Windows Copilot, which is the new AI that's built into Windows 11. And I put together a description of the sort of thing I was looking for, and that's what it generated. And this is the wonder of AI, really, isn't it? Right. Any other votes? No. If you're not intending to buy a T-shirt, you can still vote, by the way. So choose choose which one you like. What I will do, I will just go back through them one more time. So obviously that one is number 6, number 5. Hang on, that's not working, is it? Right, let's try again. Let's go back to the beginning. Sorry, I'm all fingers and thumbs this evening. Right. Okay. So let's go through them again. Number 1. Number 2.
They're not changing.
Not showing up.
Not showing. Still
We're
not showing.
stuck on 6.
Oh, okay.
Yeah,
Right. Yes, I know why. Just give me a second. Yeah, I've got a slight technical issue, but luckily I can solve it.
Operator error.
Yeah, sure. That's enough of that talk. I have the power, I would remind you of that.
Blame the newbie on the AI.
Bothered.
Okay. Right. Okay. Just give me 1 second and we'll
Pop it cap.
just sort this out. I've got a sticky slideshow, but I know why. Okay. One second. Right. That should be it now. Okay, there we go. Right. So one more time through the slides. So this is number 1. Number 2. Number 3. Number 4. Number 5. And number 6. So there you go. And if we have a look, how we're doing with the voting?
It seems to be all version number 1.
Yeah.
Derek says, "Sorry, Andy, don't like any." But then
Well,
again,
that's
he-
fine.
no.
We're not, don't
he
worry.
did ask earlier for a cloth cap, so I think we're showing his age there. Bit of an Andy cap there. So yeah, moment, so.
Okay. Well, it looks like predominantly number 1 is the one of choice. Yes, by the look of
Yeah,
it.
looks like it. Yeah.
Okay.
Thank you very much for your choices.
Yeah. Thank you very much for your votes. We do appreciate it. And we will get that underway, and we will let you know as soon as we have any news about that. So there we are. So finally, well, not finally, but we are now going over to Keith, and just let me line that up for Keith. Okay, so Keith, back to your meteorites.
Yeah, let's go back to those first. Yeah.
Okay.
Yeah, because he's got solar eclipses as well.
Well, specimen A is actually a piece of basalt lava. And it's come from Ascension Island, actually. And the holes in it are due to the gas that was in the magma when it erupted from the volcano. So this is an Earth rock. But if you look at pictures of rocks on Mars, they often look very similar because there's a lot of basalt on Mars as well. And it's got the holes in just like you see in this Earth specimen here.
It's also the sort of holes that you get in pumice, isn't it? That's what makes
yes,
pumice
that's
so
right.
white.
Yeah. The technical term for them is vesicle. They're called vesicles. Right. And if they're filled with mineral material, which they sometimes are, then they've got another technical name, and they're called an amygdal.
Oh my God.
But basically, don't worry about the names. Anyway, it's basalt, it's Earth-based.
Right.
But having said that, if you've got a meteorite specimen that has allegedly come from Mars, and there have been a few found, then it might well be something like this. But this one isn't. And since it's actually quite large, it definitely isn't. Right, okay, let's move on to specimen B. Now, specimen B is quite notorious because museums on the south coast of England get these brought in all the time by people who think they're meteorites. It is, in fact, a marcasite nodule. Jewelers know it as marcasite. It's an iron sulfide mineral with a brassy luster. You can probably pick that out there.
Yeah.
And it weathers to a sort of rusty finish, hence the fact it's going brown in places. Now, these marcasite nodules are found in the lower chalk strata of the Cretaceous period. So, for example, if you step down onto the shoreline at Eastbourne and walk westwards towards Beachy Head, you'll see lots of these in the rocks. Some of them are quite large, much larger than this one.
Right.
And if they've been picked out of the rock by wave action, when you pick them up, they feel quite dense as well, which of course tends to reinforce the idea in people's minds that they've got a meteorite, but unfortunately they haven't. These minerals form around the rotting corpses of fossil creatures that have died in the chalk ocean about 66 to 70 million years ago.
Wow.
So there we go, moving on.
Another earthing.
Another earthing, yeah. Now, if you said this one was a meteorite, you'd be absolutely right.
That's great.
I thought it was Toblerone.
Yeah, I thought it was Nougat or something.
This is a type of meteorite that's broadly classified as a stony iron meteorite. And what you're actually looking at there is a lot of metal, which is an iron-nickel alloy, mixed with chunks of olivine, which is a iron magnesium silicate. And these originated from the core mantle boundary of large, dwarf planets that used to be orbiting in the asteroid belt, and which have broken up in early solar system history, and bits of their content scattered all over the place. So from these planetoids, if you like, we have differentiated materials. We have mantle material, we have core material, which is iron nickel, and we got this boundary layer between the two, which is what you're looking at here. These are fairly rare because being a boundary material, there's not that much of it in each of these former dwarf planets. But so they do fetch a lot of money. This specimen I'm holding in my hand here is, it's a good 80, 90 quid's worth. So you do need to get your hand in your wallet to get hold of one of these.
It's rather beautiful, though, isn't it, Keith? Rather beautiful.
Yeah, they are arguably, for me, and I'll just go back to it quickly, I think they're the most striking of meteorites. Yeah, they are. This, isn't a meteorite, although one might think it is. What gives the game away is that it's surrounded by lots of smaller pieces of something similar. This whole thing, the whole picture there, is a picture of the Pebidian Tuff, which is a rock formation out in Pembrokeshire in Wales. And in fact, what it is, it's material that's blasted out of a volcano. And this happened in the Proterozoic about 600 million years ago. And the large object in the center is what's often referred to as a volcanic bomb. It's a large chunk of material that's been shot out of the volcanic crater and come crashing down and is buried amongst the finer debris surrounding it. Obviously, if you were standing there at the time, you'd probably get bounced by it. So it was pretty dangerous stuff. So that's another Earth specimen.
Whereabouts in Pembrokeshire, Keith?
Oh, sorry, St David's Peninsula.
Right.
On the south side of Porthlixie Bay. Yeah, it's around there. All right. Okay. Now, this specimen is not only not a meteorite, but it's not even a rock. You'd be amazed how many people bring these to museums. It's a piece of furnace slag from a blast furnace.
Yeah, you slag.
Human beings are extremely good at scattering their rubbish all over the landscape, and people pick them up thinking they're rocks, and they're not. They're often very pretty, though, and it can be quite colourful.
Yeah, I dig some of that up in my garden, because we had at the back of us, we had a farm, and they had a foundry in there, so it's all over the place. It really is.
Yeah. Well, I've got a concomitant story to go with this, and that is that I once ordered some iron nickel meteorites, and when they arrived, there was a note of apology from the suppliers, saying that they'd had a shipment out of China because an iron nickel meteorite had landed there in just about 1614, if I remember correctly, and bits of this had been collected up and shipped out by the Chinese. Well, when they arrived in Britain and they opened the crate, they found that not only was there genuine pieces of meteorite in there, but an awful lot of pig iron, which was left over from a rather bizarre social experiment in China during the communist era called the Great Leap Forward, where they got small villages smelting their own poor quality iron. And so the Chinese merchants had decided to throw some of this in with the genuine meteorites in the hope of, making more money. So anyway, there you go. Anyway, it's a piece of furnace slag and not a rock at all, really.
Right.
Okay. Now, this actually is a bizarre mineral known as chiastolite, and it's found in metamorphic rocks. And what someone's done is they dug this out of a metamorphic rock and then polished it up. And it's always very distinctive because it has that cross shape to it. You can see the dark cross shape running through it. And so chiastolite, I'm afraid, is another Earth specimen. So again, it's not a meteorite. And finally, the last one, this is a meteorite. This is what is known as a chondrite, which is a mixture of rock minerals and bits of metal, iron nickel, in blobs, as you can see. In fact, the blobs are called chondrules, hence the name chondrite. This is primordial planet building material. If you imagine a planet put through a blender, this is what you'd end up with. You'd end up with a whole mixture of stuff together like that. But of course, the analogy is a bit of reverse thinking, because the primordial solar system material started off like this, and then when it formed into planets, it got separated into the various layers, not the other way around, which is implied by the blender analogy. Now, what really gives this away as a meteorite is actually at the top. You can see the outside glassy crust, very fine-grained glass-like crust at the top there, which appears grey in this picture. Meteorites look like that on the outside because as they enter the Earth's atmosphere, adiabatic pressure in front of the meteorite as it slams through the air causes the meteorite to get very hot and the surface to melt. By the time they reach the ground, though, they've cooled down. So if you see people in films picking up hot meteorites off the ground and dropping them because they burn their fingers, it isn't true. They're actually cold by the time they land. But there we go. Anyway, that glassy crust is the giveaway, and the internal texture is a typical chondrite. So there you go. Those are your
Thank you.
specimens.
Yeah. I mean, to me, this looked like, I don't know, some sort of brachia. You know, it doesn't.
Yeah, it does, doesn't it? Yeah. That's why that crust is so important to distinguish it from this.
Sure. Yeah.
Obviously, of course, at the end of the day, what people do with these things is they do the geochemistry, which of course is a giveaway, and also they do what are called thin sections. They cut slices off them, polish them down to 0.03 millimeters thick, and look at them under polarizing microscopes, and then the mineralogy is very much more apparent.
Yeah, sure. There we are. Well, thank you, Keith. That was most interesting, and I have to say most of the ones I thought were meteorites weren't, and vice versa. But
they're not a dinosaur poo inside.
No, absolutely.
Yeah.
So thank you very much for that. You have, I believe, another presentation for us.
Yeah, it's fairly brief. I'm just going to whiz through these.
Let's have a look at that.
Yeah. I thought I had a look through my picture library to see if I could find any pictures of eclipses that I'd taken over the years, and I did find some. Basically, you first of all, I've got to get the joke in.
Oh no!
And of course, for what it's worth, that is not how I equip myself to look at an eclipse. Anyway, there we are. I bet a few people did, though. As several people have said, actually, on the internet, they said, if your equipment goes wrong, just stop and just watch it, and enjoy it. And I think they're right. Anyway, there we are. Right. Now, the 1999 eclipse was widely seen in southern Britain. And indeed, I mean, most of people who had clear sky saw the sun covered up 98%. But I decided to go down and stand in the path of totality because, as everyone tells you frequently, you can't, 99 isn't good enough. You've got to see the 100% eclipse. Well, needless to say, the British weather did what it always does. It clouded over, as you can see in the top left picture there. And indeed, it went dark, yes. The temperature dropped, yes. On the horizon, you could see light, but you were dark where you were standing, which is what you'd expect. And yes, there was a dawn chorus. Those wood pigeons you see on that roof there, they roosted when it went dark, and they came to life again when the light came back. It shows that the average bird has a memory retention of 3 minutes, I think. Anyway, there you go. The bottom left picture shows a data logger I took. I thought I'd see if the radiation levels changed. Couldn't pick anything up useful from that, but I also took a data logger with a temperature probe, and that did show a 3-degree drop at the middle of totality. So there you go. Right, okay, moving on. Hang on a minute. Right, I'll use that. Anyway, 2006, I took this picture here. Now, actually, this does illustrate one of the sort of possible problems, but also possible benefits of cloud. If the cloud isn't thick enough to obscure the sun completely, you can actually watch a partial eclipse without blinding yourself. And this picture was taken with an ordinary telephoto lens on the camera without any filters, because enough of the light was blocked by the clouds. Anyway, that's the 2006 one. In 2008, we had another partial eclipse in August, and some Open University students there on the bottom left there looking through a Coronado, which is a hydrogen alpha scope. But this picture was just taken with an ordinary telephoto lens again. And again, the cloud actually enabled me to take a picture without filtration. And then there was that amazing one in 2015. In southern Britain, quite a lot of the sun was covered up, as you can see from the bottom left image out of this sequence here. So that was quite amazing. And it was actually my final year working at my school as the head of physics. And we got everyone out on the lawn to watch this eclipse. It was totally unofficial, completely disrupted the school's teaching program that morning, but it was worth it. And I got 1 or 2 pictures from it. The first thing is, of course, to see an eclipse, you have to be in the right place. And these pupils you see in the picture here are from Japan. And of course, Japan was in darkness. It was midnight in Japan, more or less, when this eclipse took place. So these lucky souls were on the right side of the world to actually watch the eclipse, which was kind of nice for them, really.
Yeah.
And they're using, the bottom right picture shows you they're using a mobile phone camera with a small telescope. And the telescope is fitted with a piece of Barder filter on the front, which blocks out most of the sunlight. And Barder filter is spelt B-A-A-D-E-R. You can buy sheets of that. You can even get it off Amazon, I've discovered. Comes in A4 sheets, and you cut it to whatever shape you want to put in front of your telescope.
Keith, I remember that eclipse well. Our society went to a local school
Yeah.
to give loads of information. One of our members gave talks to the pupils, and we unfortunately the headmaster had seen something on the television about how dangerous it is to look at the sun. And told the students not to go out and meet us in the playground to look at the sun.
Oh dear.
Even though we'd arranged everything with them, with all the equipment and that. Yeah. And just like your photos say, some kids did come out between lessons and started taking pictures through the telescopes with their mobile, you know.
Yeah.
Yeah.
It's a shame when people get a bit too health and
And
safety.
especially when the headmaster was a physics teacher, you know.
Well, he should have known better.
Yeah.
Mind.
So anyway,
Yeah.
Well, in fact, actually, one of the things about the Barda filter, because we had some offcuts left over, and one enterprising young lad made his own solar specs, as you can see there, using the leftover bits of Barda filter. He didn't have it for long before one of the teachers pinched it, as you can see in the bottom right there. He got it back again anyway. This young fellow on top left there took the paper recycling bin out of his classroom and made a giant pinhole camera out of it. and you can actually see that it's quite hard to make out, but there's a small white dot at the back of the bin there. You can just about make out on the bottom right of the picture. And I've blown it up here in the bottom right picture here to show you. And you can see the image of the sun with the moon crossing it. So that was quite clever of him, I thought.
Yeah, very resourceful.
And then, of course, inevitably, the colander experiment is absolutely de rigueur, isn't it, these days, if you're doing an eclipse. And you can see the crescent-shaped, partially covered sun reproduced many times over on the cardboard at the back there.
That's a date for your calendar.
That really went really well. Yes. And as you can see, when the eclipse started, there were a fair number of people on the lawn, but by the time it was going, you can see it got very, very busy out there. We got something like about 8 telescopes out in total, so everyone did get a chance to have a look. We had hydrogen alpha scopes and Barda filtered scopes in order to do the job. So that went extremely well. And then we come on to the 2021 eclipse, which I photographed with a 600mm telephoto lens and a Barda filter. And that's what we got there. And you can see actually at that stage the sun was pretty quiet. There's no particularly strong surface features visible in this image at all. And then moving on, we got the 2022 eclipse, and the picture taken on the left there was taken with the 600mm again without filtration, simply because it was so cloudy that we were able to do it. But getting the telescope aimed at the target was quite difficult because we'd have to swing the thing round and try and catch the sun when it briefly shot out from behind the clouds, because the telescope was fitted with filtration, of course, and as a result of that, you couldn't see anything until the clouds cleared. So I had 30 seconds literally at a time to get the telescope aimed at the sun. But I did it. I got it. And you can see the picture there on the right. And you can see a few smudges of cloud on the sun's surface, but also you can see some sunspots left and right and a few smaller ones in the middle, and some plages, faculae or whatever they call them, on the right-hand side there, on the right-hand limb. So there you go. That's done with a different type of filtration, and I'm going to bring this up now. This is the kit I use for that. It's 80 millimeter f10 refractor, and on the back of it I've got a Herschel wedge. Now all it is, believe it or not, is a box with a piece of glass in it at 45 degrees. And when the sunlight hits the glass, about 5% of the light travels up towards the camera, and the other 95% goes through the glass and comes out the back. Now, that means, of course, that the amount of light that the camera is receiving is not dangerously high. And you can also see one of the fringe benefits is that because a lot of the sunlight comes out the back of the box, if you've got a ground glass screen on the back, you can actually see the spot of the sun on the ground glass screen. So you have to aim the telescope. And if it's starting to drift, as you can see here, the sun's drifting towards the top of the ground glass screen, you can make a correction.
What a great
but you
idea.
can see it anyway through the camera, of course. The other thing is the glass reflection off the glass is polarized. It's plane polarized. So with a polarizing filter fitted into the top of the Herschel wedge, it's actually possible to further filter the light from the sun. And the picture you saw previously was taken with that gadget there. And I was very lucky with that because they're over £250 now to buy, but somebody was selling one secondhand for £100. And I thought there must be something wrong with it, but no, it was absolutely fine. It was almost brand new, in fact. You can only use these with refracting telescopes. If you try using them with reflectors, then the reflecting telescope itself may be damaged, and up to 6-inch aperture on the refractor. If you go higher than that, then the amount of heat generated is too high.
Too much.
In fact, you can see that it gets warm because you can see the back of the Herschel wedge there has got a little grill-like filter at the top to let the warm air out. So there you have it. That's how it was done. So that previous picture, and I'll take you back to it, was taken with one of those.
Fantastic.
Wow, amazing. Absolutely amazing.
And that's it. Okay, folks.
Thank you very much. That's a remarkable set of images, and it just makes me sort of, want to see the total eclipse as much as I can, as soon as I can.
Yeah.
And so,
I mean, I use a Herschel wedge as well for my solar imaging as well.
You do, don't you, Roger? Yeah. Roger's
very
pictures
good.
are better than mine, by the way, because I think what you do is lucky imaging, don't you? You take a set of images and then
Merge them together. Yeah.
Mine are not as good because they're just one-off shots, you see, and the atmosphere ripples basically.
Yeah,
that's all right.
Okay, thank you very much, Keith, and very, very interesting. And lastly, this evening we're going to come back to Daz, who posed you 2 questions at the beginning of the program. So let's put this one up.
Right, I asked you what this was. But just watch it through. Boomf. There you go. That was actually... Sorry.
I said it's not what Astro Lee put in the comments.
Oh, I didn't see what he put.
Hang on, let me find it. What did Astro...
Which was cloudy skies in Sparkford.
Yeah, you can see the sparks. Yeah, see the sparks. Yeah, actually, what it is, it's the Parker Solar Probe, and this happened. This was announced last week. Of course, the Parker Solar Probe was launched in August the 12th, 2018, and what it's actually doing here is it's actually its closest flyby so far through the sun's atmosphere, and it's actually passing through a CME, which is a coronal mass ejection. And of course, they did wonder whether or not if the Parker Solar Probe actually met a CME while it was flying through, whether or not it would survive. Well, this answers the question. And apparently, they've been looking at these images. They've slowed them down. They've done still frames, and they are finding so much information. And this is what they were wishing for. So this is the closest pass so far by the Parker Solar Probe, and it's actually passing through a CME. Of course,
you can actually see the Milky Way through. Halfway through this.
Yeah, there it goes.
There it is there,
and a couple of planets, I think, as well. Probably Venus.
Yeah.
Probably Venus and maybe the Earth, possibly.
Yeah, maybe. Yeah, I've forgotten about the Earth, of course.
But as I said, but the Parker Solar Probe has a very elliptic orbit. It uses Venus as a slingshot which increases its speeds and alter the orbit to pass closer to the sun on every pass. This pass was just 11.5 solar radii from the sun's surface. So it makes it the closest man-made object to ever pass by the sun. And the next Venus encounter, because it's on its way back again, will be in November this year. And this will tighten the actual orbit so that when it goes back to the sun, it'll only be 9.45 solar radii. By the end of its actual mission, the actual probe will be actually traveling at 364,660 miles per hour, which is 586.860 kph, kilometers per hour, and it will. And so it's going to be traveling hellishly fast. And what at the moment it will be passing on this its closest pass will be 3.83 million miles above the surface, and it will be which is 6.16 kilometers, a million kilometers above the surface. So that's what this is. This is what it's showing. It's still doing its passes, and that is what you're actually seeing here. It's an absolutely amazing image. And as I said, we only got this right at the end of the show last week, so didn't get a chance to show you. So I hope some of you were able to pick out what that was. The other questions I asked you, what do these three symbols represent? What planets do they actually represent? And so we'll move on, and it is Mercury, Venus, and Earth. Mercury is basically what they call the hooded winged cap of Mercury. So you've got the hooded spike cap, and then there's a cross coming down from below it. Venus, of course, is the female sign, and it's supposed to represent the hand mirror, the goddess of love. And of course, we've got Earth. And the cross in the Earth is to represent the four cardinal points, north, south, east, and west. So that's what they are.
Wow, fantastic. Thank you, Daz. So there we are. So that's the answer to Daz's conundrum tonight. You're going to have to give it a more snappy title, Daz.
I didn't call it a conundrum.
Yeah.
Yeah. There's just one more thing I would like to announce, Andy. And that is the passing of Peter Higgs. Apparently, he died last night, and of course, we all know Peter Higgs for his prediction of the
Higgs boson.
Higgs boson, and the idea is it's the thing that actually gives subatomic particles mass. He died aged 94. And he was in the 60s. Him and other physicists predicted the Higgs boson, and as I said, it's to give the minuscule matter its actual mass. And then he was given the Nobel Prize. He shared it. I'm just trying to find when it was.
2013, wasn't it?
2013. He did it, yeah. And of course, in 2012, the Large Hadron Collider actually confirmed the existence of the Higgs particle, which they then called the Higgs boson. So
that's right.
Yeah. So it's a sad pass, and he was working all the way up to the end of his death. He was actually lecturing in Edinburgh, if I remember right. Yeah, Edinburgh University. Yeah.
So R.I.P. Peter Higgs, a true professional scientist to his core. So, and we must be so glad that the boson was confirmed after so many decades of it being theoretical, and it was an amazing achievement to predict it. And obviously, Mr. Higgs has now left us. So R.I.P. Mr. Higgs. I'm sure you will be missed by everybody inside.
Yeah, sorry, he shared the Nobel Prize with Francois Eglert from Belgium.
That's right.
For their discovery. Thanks.
Yes, absolutely. Thank you, Daz. Ian has come up with a a suggestion for what you could call your weekly questions. Daz's Dazzler.
I think I could get arrested for that.
I think you probably could, so it's probably not a good idea.
Daz's Dazzler.
But thank you anyway for the suggestion.
Yes, thank you, Ian. We'll work on that.
This is a family show, even though we've got Daz on it. So there we are. Okay. Well, that brings us, I believe, to the end of this evening's show. We'd like to thank you all very much for your attention and patience with us this evening. We hope you've enjoyed the show. We'd like to thank those of you who bought us coffees. We'd like to say again a big thank you to people who've bought us super chats as well. Don't forget you can donate a fixed amount of however vast it is to Space Oddities. Doesn't matter how big it is, honestly. By just clicking the super chat icon underneath the main window in YouTube. So thank you all very much for your support. We will be back, of course, same time next week, where Lou will be delivering his presentation about his Eclipse experiences, and we'll have the usual regular features and some stuff that we're not quite sure about yet. So we hope you can join us again next week, same time, 8 p.m. UK time, 3 p.m. EST, on Space Oddities. So we'd like to say thank you for everything, and good night from the panel. Good night, Michael.
Good night. Good night. Good night.
Good night, say good night, Roger. Good night, Roger.
Good night, Roger.
Good night, Roger. Good night, Daz.
Good night, everyone. Keep
Good
looking
night,
up.
Good night, John Boy. Yeah. Good night, Keith. Thank you for your presentation tonight. Very, very interesting. And for me, it's good night from me, and it's good night from them. Yeah. So thank you all, and we'll see you again next week. Have a fantastic
Thank you, everyone.
Stay safe, look after each other.
Bye.
And enjoy your week. We'll see you next week.